All right, so let's start Unit 3 off with graphing parabolas. So let's start by saying a parabola is the graph of the quadratic function, which you can write in the form f of x equals ax squared plus bx plus c. AKA there's up to 3 terms, and there has to be an x squared in the first term, or in one of the terms, I should say. Okay, so here is the parent function. So this is really important to memorize because we're going to be using this. I'm going to be referencing this a lot. So I would definitely take really good notes on this part. So first, if you don't know how to graph something, I always say make a table and let's plot some points. So I'm going to tell you which points to pick just to kind of speed things up. But let's pick -2, -1, 0, 1, and 2. So this gives me points on both sides, or positives, negatives, and 0. So let's go ahead and graph it. So if I were going to plug in -2, this would be like -2 to the second power. So the y, if you want to cross that off and put y, if that helps you, you can. That would be 4. Okay, and this would be -1 squared, which would be 1. And it's really important that you have parentheses on those two because it matters. If you don't, it will give you the wrong answer. 0 squared is just 0. 1 to the second power is 1. 2 to the second power is 4. Okay, so I'm going to go ahead and plot these. So go over to -2 up to 4. -1, 1, 0, 0, 1, 1, and 2, 4. Okay, so zoom in on this and let me see if I can graph. Let me try. If you're on Notability, it will let you make them pretty. Okay, so here's our graph. Some things I want you to notice. So this piece right here in the center is the vertex. So on the parent function, the vertex is at 0, 0. Okay, so another thing I want you to notice is there is this line right here, and this is called the axis of symmetry, and you're going to see that a lot. And this is a vertical line, always, for this class anyway. And so vertical lines, you're going to have to write it as an equation because it is a line. So it's going to be x equals, and it's always x equals, and that line is at x equals 0. Okay, so on the Delta Math, it's going to ask you the axis of symmetry. That's what it's talking about. Okay, some other things I want you to notice is here. You notice from here to here, it's over 1, up 1. Over 1, up 1, right? Okay, let's do another one. Let's see if I can do this. Oh, I don't like that color. Let's try red. For red to go up to here, it's over 2, up 4. Over 2, up 4. And if I was going to do, let's say another one, let's say if I was going to pick the point 3, that would be 3 to the second power, which would be 9. So over 3, up 9, right? Then to the left, if you were going to do -3, it would be over 3, left 3, up 9. So my parabola is very off, but that I drew. But that's kind of the idea, and that's the parent function. So it would definitely be worth your while to have that memorized, that it is over 1, up 1, over 2, up 4, and over 3, up 9. Okay. All right, so vertex. Oh yeah, we already labeled it. So the vertex is at 0, 0. The axis of symmetry is x equals 0. You always have to have x equals. You can't just put 0 because it's wrong. Domain, how far left does this go? Looks like it goes left forever, so that would be -infinity. And the upper bound for domain is +infinity because it goes to the right. the range, the lowest point, the minimum, would be at 0, and it's a bracket because it hits 0, and then it goes up forever to positive infinity. Okay, so vertex form. This is going to be your best friend. So it is f of x, or you could put y, it doesn't matter, equals a parentheses x minus h parentheses squared plus k on the outside. Okay, that's definitely something, if you have a note card, put on your note card. Okay, so the vertex of the parabola is hk. The axis of symmetry is x equals h. And I'll talk about what the a does in a second. So here, this is just like whenever we were graphing those absolute values. It has very similar, all these functions in this class have pretty similar characteristics. So if it's inside the parentheses, that's being raised to the second power, and it's plus 2, it's the opposite. Just like on the absolute value, the left and right is the opposite of what you would think. So this is left 2. And therefore, if it's x minus something in the parentheses, that would be right and 3 in this case. If it's not in the parentheses, then it's on the outside, so the positive 4 would be up 4. And this one, if it's minus 1 on the outside, it would be down 1. What do you think the 1/2 out front means? Remember your absolute value rules? This is actually a shrink by scale factor 1/2. So that means it's wider, just like on the absolute value graphs. The 2 up front, so since it's bigger than 1, a number bigger than 1, that's a stretch by scale factor 2, which means that's more narrow, like just like on the absolute values. And then the negative out front, just like the absolute values, means reflection across x-axis. That's the only reflection. There is reflections across the y-axis, but we're not going to do those in this class. Okay. So let's go ahead and graph. First, let's identify what is happening here. Looks like it's almost like the parent function, except it's being reflected. So it's a reflection, and that's it, right? So normally it would start at 0, 0, the vertex does of the parent function, and since this is not being shifted, it's just you put a point at 0, 0. But now instead of going over 1, up 1 like we were doing on the other ones, we would go over 1, down 1 in both directions. And then do you remember over 2, down what? Well, in this case, it's going to be 4, right? Because 2 to the second power. So, oops, sorry, can't count. So that would be right there in both directions. So left 2, down 4. And just for fun, let's do another one. Over 3, down how many? 9. Over 3, down 9. And again, the reason we're going down instead of up is because there was that negative out front. So let's see how good I can draw this. Pretty terrible. Perfect. Okay, let's do another one. So this one's a little bit trickier. This one has a stretch, or I'm sorry, a shrink, my bad. A shrink by scale factor 1/3. So this means it's going to be wider. Okay, so what you do is whenever you go up, you multiply the number by 1/3, or aka divide it by 3. Okay. So usually, we always start at, this one doesn't have a shift, so I'm still going to start at 0, 0. I got to zoom way in on this. So usually I would go over 1, up 1. right? But instead of going up 1, I'm going to go up, and I'm going to just write this down, I'll erase it. 1 times 1/3, which would be 1/3. So let me erase all this. So instead of going up to over 1, up 1, we're going to go over 1, up to 1/3. Oh, this darn eraser. Okay, so over 1, up 1/3, which would be about right there. Let's go the other direction. Okay, so now we would normally go over 2, up 4, right? But now we're going to do over 2, up 4 times 1/3, which if you put in a calculator is 1 1/3. So it would be about right there, right? So over 2, up 1 1/3. And then let's do another one. You usually would go over 3, up how many? 9. Oops. 9. So instead of going over 3, up 9, we're going to go over 3, up 9 times 1/3, which is 3. So this would be over 3, up 3. Over 3, up 3. And that makes kind of a baby wide parabola. Okay, so you can see it's a little bit wider than the last one. Okay, what's happening on this one? Looks like no shrink or stretch, no reflection. We just have a +3, so that means up 3. So normally we would start at 0, 0, but now we're going to start at going up 3. There's no shrink or stretch, so it's over 1, up 1 in both directions, over 2, up 4 in both directions, and then over 3, up 9 in both directions. It'll be somewhere around there. It's off the graph a little bit, but it's okay. Okay, here's this one. What's happening on this one? It looks like +1 inside. That means left 1. Nothing else. So left 1. So over 1, up 1 in both directions, over 2, up 4, over 3, up 9. Draw it. Looks like that. Okay, so now this is a little bit different. What do you notice? There is an inequality. So remember, this is less than, so that's going to be a dashed line. And we're going to have to shade, so don't forget the shading. Before we worry about all that, let's just worry about where our points need to be. So it looks like this is a graph that's being shifted, left, oh my gosh, I cannot write today, left 6 and up 2. So let's do that. Left 6, up 2. Normally it would be, and there's no shrink or stretch, so it's just like the parent function, but just shifted. So up 1, over 1, both directions, up over 2, up 4, and I think we can fit it, over 3, up 9. Okay, and then remember I said this is a dashed line. Really hard. If you're on Notability, it does dashed for you. It's hard on here. Okay, so remember, we need to pick a point. Okay, which point are we going to pick? I'm going to pick our good old trusty 0, 0 because it's not on the line. So is 0 less than 0 plus 6 squared plus 2? So this would be 0 is less than 0 plus 6 squared. Remember, you have to do what's inside the parentheses first, or you could stick that whole thing in the calculator. So that would be 6, to the second power plus 2, which is 36, plus 2, which is 38. So is 0 less than 38? Yes, absolutely. So that means we're going to shade on this side of the parabola. Okay, and yes, you do have some like these in your test, that's why I'm doing them. Okay, so now let's do this one. This is a lot going on here. Looks like it's shifted. Oh, crap, this is as hard as it gets. So we have a dashed line. Let's talk about that first. Okay, so this is going to be dashed. We have it shifted. +2 is left 2. This is down 2. Looks like it's a reflection. And it's a stretch by scale factor 2. Yep, this is as tricky as it's going to get, but that's okay. So let's talk about it. Let's first get our vertex plotted. Left 2, down 2. Be right there. Okay, remember it's a reflection, so it's going to be upside down. And then it's a stretch. So we're going to, instead of going over 1, down 1, like we normally do, we would go over 1, down 1 times 2, which would give you 2. So we're going to do that in both directions. And instead of going over 1, down 4, like we would if, or sorry, over 2, down 4, we're going to do over 2, or over 4. So let me start over. Instead of going over 2, down 4, we're going to go over 2, down 4 times 2, which is 8, which would be about right here. So this is going to be more narrow. Okay, I'm not going to worry about it anymore because it'll be off the graph. So let's draw my dashed line with my arrows on the end. Let's pick a point, 0, 0. So is 0 greater than -2 times 0 plus 2 squared minus 2. So this time I'm going to do a little bit different to speed up time. I'm just going to stick all of this exactly how it's written in my calculator. Okay, and when I do that, I get -10. So is this true? Is 0 greater than -10? No. So we're not going to shade on that side that the 0, 0 is marked. We're going to shade on the opposite side, which would be inside this parabola. Okay, let's do another one. So a lot happening here. It looks like I have a solid line. Okay, but there is going to be shading. Looks like left 2, down 5, and a shrink. So it's going to be wide by scale factor 1/4. Okay. Left 2, down 5. Okay, zoom way in on this. So, okay, so usually it's facing up, right? It's a U. So usually we would go over 1, up 1. Now we're going to go over 1, up 1 times 1/4, which would be 1/4. So just a little bit up. Usually we would go over 2, up 4. Now we're going to go over 4, up 4 times 1/4, which is 1. Let's do the last one. Over 3, or sorry, yeah, over 3, up 9 usually, but now we're going to do 9 times 1/4, which is 9/4 or 2.25. Just to give you a heads up. If you want to use a calculator, that's perfectly fine. So over 3, up 2.25. Okay, and we said this is a solid line. Looking a little crazy, that's okay. So let's go ahead and test our test point. 0, 0 is 0 less than or equal to 1/4 times 0 plus 2 squared minus 5. Again, stick all of that on the right side into your calculator. Okay, when you do that, you get -4. Is that true? Is 0 less than or equal to -4? No, again, so we're going to have to shade on the opposite side. Okay, last one. So we've got, it's going to be a solid line, right? Oops. Solid line. Okay. It looks like it's a reflection, so it's upside down. No shrink or stretch, cool. then it's going to be left 2, up 4. Okay, so left 2, up 4 would be about right here. It's a reflection, so it's upside down U. So no shrink stretch, so regular parent function, so over 1, down 1 in both directions, over 2, down 4, over 3, down 9. We said it was a solid line. Okay, this one, I'm glad we're finishing on this one. You can't pick 0, 0 on this one because 0, 0 is on the line. So pick a different number. I'm gonna pick 1, 1. Okay, so is 0 greater than or equal to negative parentheses 1 plus 2 squared plus 4, put in your calculator, and you get negative 5. Is 0 greater than or equal to? Yes, it is, so I'm going to shade on that side. Alrighty, and then that is it for this lesson. Thanks for watching. Have a great rest of your day.